As it was proved by Dalton that matter is made up of small particles called atoms, and we knew many things about matter now, the classification and all. Then the second question which came to our mind was that what actually is the structure of the atom? Like it is it composed of certain particles, what are the arrangement, or we can know anything, we can know everything about an atom by knowing its structure. So the second question was what actually the structure of atom was. So many scientists were trying to find out the structure of an atom, but the first volunteer was J.J. Thomson. So keep in mind that J.J. Thomson was such a volunteer that he made the first attempt to discover the structure of atom, and also he made the first attempt to discover the subatomic particle, that is electron. As I told you before that the subatomic particles electron, proton, neutrons were discovered, but the first discovery was done by J.J. Thomson. So J.J. Thomson somehow failed to explain the structure, but still he made the first attempt. So let's see that how he made the attempt and what was the reason that his model failed. So he according to him, when he was giving the structure of atom, he said that atom is positively charged sphere. This he concluded by performing various experiments. So he said atom is positively charged sphere, means a sphere which has uniform positive charge distributed all over, right? Then he said that it contains the few negative charge particles. It contains the few negative charge particles like this, and the arrangement is such that you must have seen the cake, right? When we see a cake, it is beautifully white cream, or you say a strawberry flavor or pink, the color can be anything, you know? So that means the whole color of the cake is one, but it has the red cherries embedded in it. So he compared the model with the plum pudding model, yeah, or you can say the watermelon. He said as the cake has cherries in it, so likewise the atom has, the positive charge atom has the fewer electrons acting as cherries in the atom. So that means he compared the model, compared the electrons with the cherries and the cake base with the atom, this positively charged sphere. And he said that he named his model as plum pudding model. I am repeating again, just listen it carefully. He said that atom is positively charged sphere with few negative charges scattered all over, right? And the model was called as plum pudding model. Now the question I think which is striking in your mind is that it is the observed fact that opposite charges attract each other, right? We know opposite charges, positive can attract negative, negative can attract positive. So that means opposite charges attract each other. So how is it possible that so many positive charges are present and they couldn't attract the fewer negative charges which are scattered in the, you can say, the sphere? This is not possible because they would have been neutralized by such huge positive charge. So this was the main, you can say, the limitation that J.J. Thomson failed. Actually, you know what he said in his favor? He said that the negative charges are such that we can, listen to me again. He said that fewer negative charges are scattered. So he knew that opposite charges attract each other. He knew that many scientists will raise a question that how come it is possible, like the question same coming in the mind, that how it is possible that fewer negative charges remain scattered in a huge positive charge sphere. They would have been neutralized. The positive charge would have been neutralized, this small negative charge. But he said that the repulsions between the negative charges, the repulsions between the repulsive forces between the negative charges are just balanced by the attractive forces which they are experiencing from the center of the atom. So he said because these forces are balanced, the repulsive forces between electrons and the attractive forces which the electrons were experiencing from the center are actually balanced, and he said that is why these electrons remain scattered. but it was so sad to believe that this model actually failed, because it is not possible that fewer negative charges remain scattered whether the forces are balanced or not, but still it is impossible for this kind of structure to exist in nature. That is why we say that he failed to explain again the stability of an atom. But no worries, J.J. Thomson was still a volunteer. To make a first invention or to make a first discovery is a great achievement. It doesn't matter it fails or it succeeds, but still you can say the attempt was a good one.